This is the second example problem video for simple differentiation of parametric valued functions. So I'm going to let you try this one. Come back when you have an answer or if you have no idea what's going on. Pause the video. Okay, so finding a derivative, first derivative, it's the first thing I'll do, dy dx. I mean, this is pretty simple. We just have to remember the formula. So finding the first derivative, right, it's just it's dy dt over, so dy dt in the numerator, and then in the denominator is dx dt. So so first we have the derivative of y, derivative of 5 sine 3t, right? So that is going to be, well, that requires a chain rule. So first 5 cosine 3t, and then you also have a 3 that pops out, okay? That's the numerator, and then the denominator is the derivative of x. So the derivative of cosine of t, which is negative sine of t, okay? So there you go. That is literally all we can do after we multiply the 3 and the 5. Because you can't like combine the cosine. You can't divide the cosine 3t and the sine t or anything, because one is 3t. You're taking the cosine of 3t versus taking the sine of just t, so you can't like combine them or anything. There's no like cotangent or something you can form there. Anyway, but so then the second derivative, once again, just following the formula, doing what the formula says. This was the derivative with respect to t of dy dt over dx dt. This was the formula for the second derivative, if you do not remember. So anyway, so let's do that. So right, so that's this. So 15. So what that means is we'll have d dt of 15 cosine of 3t over negative sine of t, right? So the derivative of 15 cosine 3t is going to be negative 15 sine of 3t with the inside derivative of 3 over negative sine of t, okay? And then we multiply that, negative 45 sine of 3t over negative sine of t. Oh, the negative signs cancel out, so you just have 45 sine of 3t over sine of t. Once again, you can't combine. You cannot combine these signs because one is the sine of 3t, one is the sine of just t, so you cannot combine them. And that is literally it. That's the first derivative and the second derivative right here. And as I pointed out in the first example problem video, that your second derivative, that I pointed out that this one there is actually just the derivative of this one. In other words, that your final answer for your second derivative is the derivative of your final answer for your first derivative. Of course, we know this from first year calculus. It's not like, oh my goodness, second derivative is just the derivative of the first. Obviously, that is true, but I mentioned that in the first video because it just shows a shortcut, that instead of going through the complex formula for a second derivative, ideally, once you get your first derivative, you could just take the derivative of that to get the second derivative. It's interesting to point that out for this question, because I look at the first derivative, I look at the second derivative, and I'm like, wait, the second derivative is the derivative of the first? These don't look like they're related by derivative / antiderivativeness. I mean, I'm saying the second one, this one does not look like it's the derivative of this one, but I'm guessing somehow you could differentiate this one and end up with this one. I'm guessing somehow you could. Probably there's some like trig identity you have to pull out at some point or another so that it ends up looking like that. But anyway, so yeah, these are the first derivatives and the second derivatives here for this problem number 2.